Now, wireless is not just something that we're integrating into our products, but increasingly it's being added to the products that you're designing and building. Over the last few years, National Instruments has been dramatically expanding our range of high-performance instrumentation with a significant investment in RF and wireless test. To talk about new technologies we're offering for RF, please welcome from engineering, Sayad Suskic, and product manager, David Broadbent.
Good morning.
Thanks, John. Every year, wireless devices are growing more complex. And today, it's common to find multiple standards, such as GSM, Wi-Fi, Bluetooth, GPS, and many others, all incorporated into the same device. Now, what that means for us is more measurements, and yet still trying to reduce overall test time. And that's a tall order. And yet, with software-defined instrumentation, one of the biggest benefits is measurement speed. With high-performance multi-core CPUs and PXI, you can make measurements faster than ever before.
That's right. Last year, for example, we released the 6.6 gigahertz RF instrumentation suite and made a side-by-side compare that put us at about 4 times faster than a traditional instrument. Since then, we've made a number of improvements, such as faster tuning times and a feature called RF list mode. Traditionally, switching from one RF configuration to the next incurred a significant overhead, which adds to overall test time. But with RF list mode, you provide a list of RF configurations ahead of time, shaving off precious milliseconds from test.
That's right, and to demonstrate, we have a PXI system with RF list mode and our new PXI Express 8108 controller running a series of tests on a power amplifier alongside a traditional instrument performing that same set of tests. Now, as we begin these two test systems together, you'll immediately notice the difference in measurement speed between the traditional system and that of the PXI. Say, did you forget to start the PXI system?
Gosh, I did this almost every run-through. My goodness. Wait, let me run the PXI system now.
Thank you.
All right, so looks like our PXI system ran the tests in a little under 4 seconds. Oh, how does that compare to the traditional instruments?
Well, once it wraps up, we'll just wait a minute here and I'll calculate that for you.
Okay, David, there's thousands of people out there. We can't just tell them to wait.
Oh, I see your point. Well, it is a software-defined instrument, and we do have a little bit of time, so why don't we perform Wi-Fi and WiMAX tests with our recently released Wi-Fi and WiMAX toolkits for LabVIEW.
So let me get this straight. On our PXI system here, we just ran tests for GSM, Edge, and WCDMA, different frequencies, different power levels. We're still waiting on traditional instruments, and you're just going to go ahead and run WiMAX and Wi-Fi on the same system?
No, that's exactly right. With faster tuning times and RF list mode, we can perform measurements in a fraction of the time it takes with the traditional system. And by using our latest RF toolkits, it was simple to add Wi-Fi and WiMAX measurements as well.
Very impressive.
Now, it looks like our traditional system has actually finished up. So to answer your question, John, with using PXI, we were able to perform measurements more than 10 times, looks like 15 times faster than the traditional system.
Very nice. Thank you.
And we'll try to get faster each year, but we also understand that RF engineers have other concerns, such as prototyping and testing devices using new wireless standards. So new protocols such as LTE, Mobile WiMAX, 802.11n, all use multiple antennas through a technique known as multiple input, multiple output, or MIMO.
And PXI is ideal for testing MIMO solutions. And the reason is that its modularity lends itself to sharing common hardware between analyzers. You can provide synchronization that's just not possible using a traditional approach. In this test system, to demonstrate, we actually have 3 vector signal analyzers as well as a vector signal generator, amongst other hardware. And by generating a single frequency in the graph, you can actually see the phase offsets introduced by subtle differences in signal paths. And if I adjust for those differences within software, we now have 3 phase synchronized analyzers for MIMO test.
And not only does this give us an opportunity to do more in wireless test, lets us have a little bit of fun here on the stage.
All right, this reminds me of my first cell phone.
You know we're not allowed to have cell phones on stage, but anyway, it's a simple single frequency transmitter, and you might want to turn it around so we can see that. Oh, there you go. No, that was good. And the distance from the antenna from the transmitter to the individual antennas is causing a phase offset that we're able to measure. And with a little math, we can actually figure out where you are.
And so as I walk around, I get a finger pointing at me. I've had that happen before.
That's exactly right, John. With the flexibility of PXI, these types of solutions are possible. And it allows engineers to bring unique and complex solutions to market faster than ever before.
All right, well, looks great, guys. Thanks for showing us the new RF hardware and software. Thanks, Ed. Thanks, Ed.